I'm Seb Bolivar, Professor of Astrophysics at the University of Sussex, and I lead Hermes, the Herschel Multi-Tiered Extragalactic Survey, which was the largest project on the European Space Agency mission Herschel. The European Space Agency mission Herschel launched in 2009, and it's the biggest space telescope. It's 3.5 meters in diameter, the mirror, which compares, for example, with the Hubble Space Telescope, which is about 2.5 meters in diameter. So one of the key questions in astrophysics is, how did galaxies evolve? And one of the key parts of understanding how galaxies evolve is to understand how the stars within those galaxies formed and when that star formation took place. But the problem is that when star formation occurs, it is almost invariably accompanied by production of dust particles. And that dust acts as a sort of smoke screen and blocks out the light from the stars below. So our ordinary telescopes can't see what's going on. We're missing half of the story unless we can see what's happened underneath and through that dust. We're used to seeing light as in the optical part of the spectrum, which is the bit that our eyes are sensitive to. But the electromagnetic spectrum, or light, extends beyond that, and so if you go beyond red to regions that our eyes are not sensitive to, you get into the infrared, then into the submillimeter. The wavelength of light is getting longer and longer and longer, and the individual photons that are carrying the light are getting lower and lower energy. Okay, so what I'm doing here is setting up a demonstration of how infrared cameras can see through the dust. So what we've got here is a fishbowl representing a region of star formation in the universe. And now what I'm going to do is trigger off some star formation, and then that star formation leads to supernovae, and those supernovae throw out a material, including dust, into the interstellar medium. Eventually, that's going to block out our view of what's happening underneath. But with an infrared camera, we'd be able to see through that dust. And the key thing about Herschel is that it is able to see the emission from the dust itself. So all that energy that was lost was absorbed by the dust, blocking out the light from ordinary telescopes, is then re-emitted, and Herschel can measure that and tell us what was going on underneath, and measure how much energy was being produced in the formation of stars in the distant universe. Infrared astronomy allows you to uncover all this hidden star formation that's going on behind this smoke screen, this veil of dust, which just blocks out all that exciting astrophysics from conventional telescopes. The largest project on Herschel was Hermes, and we were using that to map large chunks of the sky, about 400 square degrees. So to put that in context, the moon, as we see it from the Earth, is about 1/4 of a square degree. So we've mapped quite large areas, and everywhere we look, we see these star-forming galaxies. We see glowing remnants of the star formation reprocessed through this dust. Before Herschel, we knew of about 2,000 of these sorts of galaxies. Today, with the observations from Herschel, we know of about a few 100,000 of these galaxies. So we've got an enormous transition from where we were to what we are today. And having found these galaxies and catalogued them, we're moving into the process now of trying to find out how far away they are and measure their properties to find out how massive they are, how much star formation is going on in each one, and so to build up a picture of how the universe has evolved from the very earliest times to the present day. I've got a number of research students working with me here, all doing different aspects of trying to understand what this sort of data from these infrared telescopes means, and what we can learn from that about galaxy evolution and star formation in the distant universe. So there's many, many years of research to come to really exploit all of this data we've got from Herschel. We've now got these hundreds of thousands of galaxies, and really the work starts to really understand what that means.